Hi, Algebra students. Here are our notes for section 4.3b on application problems. So many times when solving a system of equations, we want to see how that applies to a real-life situation. So we're going to look at some application problems today, and I know that's kind of challenging. So I put some steps in here that I hope will be helpful for you when solving these equations. So let's just read through these together first. So step one just says read the problem and decide what information is given and what needs to be found. So be thinking about things like, okay, what do I know and what do I need to find out? Are there any words that are telling me to add, subtract, multiply, divide? Like what information do I have? Step two is to determine the unknowns and write a variable statement for each. Generally, when reading through the problem, the very last sentence is going to tell us what we're looking for, and that'll help us determine what these unknowns are. And then when I say use meaningful variables, I mean instead of just using X and Y, which you can every time, sometimes we want to use variables that help us remember what we're looking for in the problem. Step three is to select the structure of the equations. So when solving an application problem, sometimes our equations are going to be written in slope-intercept form, and sometimes they're going to be written in standard form. So look at the notes I have here. Slope-intercept form equations are typically going to give us the rate of change and the initial value, but the total is what we're looking for. On the other hand, a standard form equation is usually two things that have a rate of change, but we know the total. Okay, step four, logically, is to write a system of equations. Step five is to think about how we're going to solve those. So remember, we've talked about all the different ways that we can solve a system of linear equations. So obviously, graphing does not usually lend itself to the situation. So typically, we're going to solve algebraically. So you're going to be choosing between substitution or elimination. So you want to be thinking about how we decided upon each of those methods. And then lastly, of course, solve the equation and clearly state your answer. When I say clearly state the answer for an application problem, that's actually not as an ordered pair like we usually do. You want to make sure that you go back and answer the question and either write a short sentence or at least include the labels with the numbers so that we know exactly what the question was asking us to find. So I will model all of that for you here. So let's start with example one. So we're first going to read through the problem and look for the important info. So like here, I can see that in this problem, the first taxi company is charging a $2.80 fee plus $1.60 per mile. And then I have a second taxi company that is charging $3.20 with a one-time fee of $1.50 per mile. And then we're going to end with the question that it's like, what is it asking us to find? It says, after how many miles will each taxi cost the same? Okay, so again, here's my clue as to what I'm looking for. After how many miles and when will the cost be the same? So when I set up my variable statement, those are the two things I'm looking for. I'm looking for the number of miles, which I might write as M. So again, choosing a meaningful variable, number of miles. And I'm looking for the total cost. So I'm going to let C represent the total cost. Okay, and then I'm going to set up my two equations. The equations are going to come from each taxi company. So taxi company number one charges a one-time fee of $2.80 plus $1.60 per mile is the total cost of the first company. You can also start with the capital C for total cost. It doesn't matter, and then write it in slope-intercept form. So like here I might say, well, actually, I'm just going to go ahead and leave it the way it is because I'm going to write it as I read it. So for equation number two, this is for the second company. They charge $3.20 for the one-time fee, and $1.50 per mile is my total cost. Okay, so For this particular problem, both of these are written in slope-intercept form. So what I'm going to do is solve them by substitution. So I'm going to take the value of c in the first equation, and I'm going to substitute that in place of c in the second equation. So my work is going to look like this. Okay, here's where I'm substituting. So I'm substituting $2.80 plus $1.60 m. Okay, so now I've got an equation with variables on both sides. I'm going to go ahead and solve. I think I will start by subtracting $1.50 m from both sides. So that's going to leave me with 3.20 is equal to 2.80 plus 10 cents. Okay, my next step would be to subtract 280 from both sides. Okay, I'm a little short on space here, so I'm going to scoot up around the edge here. I think when I subtract, I get 40 cents is equal to 0.10, so 10 cents per mile. And then my last step would be to divide here. So my final answer is 4 equals m. So when I go back up and look at the question, it says, after how many miles will each taxi cost the same? So that's my answer. So again, if I'm going to write a sentence, I would say, in 4 miles, both taxis cost the same. Now, if the particular problem wanted me to find what the cost was when both things were the same, then I would go ahead and plug the 4 into one of the equations and solve for c, but quite honestly, it doesn't ask that. I've answered the question, so I'm just going to go ahead and move on. Okay, question 2 says, you are making hanging flower baskets for a fundraiser. The plants you've picked out are petunias and daisies. Okay, so then it says petunias cost $3.20 each, and daisies cost $1.50 each. You have bought a total of 24 flowers for $49.60. How many of each type of plant did you buy? Okay, so there's our question that we have to solve. How many of each type of plant did I buy? Okay, so that tells me that I'm looking for the number of petunias and the number of daisies. So when I write my variable statements, I'm going to let, again, using a meaningful variable, P stand for the number of petunias, and D is going to stand for the number of daisies. Okay, so for my first equation, notice it says petunias cost $3.20 and daisies cost $1.50. I will tell you this, when we're writing an equation, a lot of times you'll have what we call a cost equation. Okay, so anytime you have money, money goes with money. So even though I kind of highlighted these 3 different ways, all the money goes together, okay? So if petunias cost $3.20 each, that means I do $3.20 times each petunia. And remember, this word and indicates I'm adding $1.50 for each daisy for a total of $49.60. Okay, so this first equation is what we call our cost equation. Our second equation is the total number of items. So we have 24 flowers total. So that means we have some petunias and some daisies for a total of 24. Now, what you might notice is both of these equations are set up in standard form. So we might be thinking like, oh, both two standard form equations, I'm supposed to use elimination. You absolutely can use elimination, but I will be honest with you. In this equation, to me, it's way more easier to use substitution. So that's the method that I'm going to go with. So in order to use substitution, the first thing I have to do is isolate a variable. So in the second equation, I'm just going to subtract d from both sides and rewrite this equation as p equals 24 minus d. And now I'm going to substitute that value of p in the first equation. So p is equal to 24 minus d. Okay, plus 1.5d is equal to 4960. Okay, so I'm going to solve my equation. The first step would be to distribute the $3.20 on the left. So 3.2 times 24 is 76.80. Okay, and don't let me fool you guys. I got a calculator right here in my hand. I am not doing this in my head. 320 times d is just 320d, so bring down your subtraction sign, plus 1.5d equals 4960. My next step is to combine like terms. So I'm going to put these two variable terms together. So 7680. And then 3.2 minus 1.5, because those have different signs, so I'm going to find the difference. The larger term is negative, so it stays negative, and then equals 4960. Okay, down to a simple two-step. So next step is to subtract 7680 from both sides. Again, I'm grabbing my calculator. 4960 minus 7680 is negative 2720. And then I have to bring down the negative 1.7d. My final step, boop, is divide both sides by negative 1.7. Okay, and I still have the negative 2720 in my calculator, so I'm just dividing that by negative 1.7, and I get 16. So D is equal to 16. So I'm going to go back up and look at the question. It says, how many of each type of plant did you buy? So if D equals 16, that means I bought 16 daisies. To find the number of petunias, I go back to the equation right here. Above it, it says the number of petunias is 24 minus the number of daisies. So 24 minus 16 is 8. So I would say, and 8 petunias. All right. Let's keep going. Next problem.
Clark Suter, if you are in the building, please come to the Welcome Center. Clark Suter.
All right, sorry about that interruption, but there is no way I'm starting this video over, so we're going to keep going. Number 3, Kristen spent $131 on shirts, okay? So that is a total amount. Plaid shirts cost $28, and solid colored shirts cost $15. And then in the next sentence, it says she bought a total of 7 shirts. And then the question that they want us to find is, how many of each kind of shirt did she buy? So that means I want to know how many plaid shirts she bought and how many solid colored shirts she bought. So to make my variable statements, I'm going to say let P equal the number of plaid shirts. Okay, and then let S equal the number of solid colored shirts. Be very careful about using S as a variable because it sometimes looks like the number 5. So make sure you're writing that very carefully. Okay, so remember, money goes with money. So all the money goes together. This and the 131, okay? So plaid shirts are $28. So my first equation is going to say $28 for each plaid shirt. There's that word and again. And $15 for each solid colored shirt for a total of $131. Okay, so remember, just like I talked about above, that is our cost equation. Okay, this is a total cost. Now we're going to deal with the total number. Okay, total number. So she bought 7 shirts all together. Some are plaid, some are solid. So P plus S equals 7. Okay, this particular system is very, very much like the one you just saw above. So again, even though they're both in standard form, I'm not going to solve this one using elimination, although you could if you wanted to multiply through and change the second equation. In my opinion, it's much easier to solve this using substitution. That is my preference. So I'm going to say, oh, I don't know why I did that, but I'm just going to go with the flow and say S equals 7 minus P. Okay, you could have also said P equals 7 minus S, and you could have solved that way. So let's go ahead and start by substituting that value of S into the first equation. So I'm going to start by saying 28P plus 15, and then we're multiplying by 7 minus P. That's our value of S we're using and setting it equal to 131. Okay, so again, grab your calculator. We are distributing here to simplify our equation. So 28P, and we're doing 15 times 7, which is 105, and then 15 times P is 15P. Okay, next step is to combine our like terms. So in this equation, I can combine 28P and negative 15P. Watch your signs. So 28 minus 15 would be 13P plus 105 is equal to 131. Next step, subtract 105 from both sides. 13P is equal to 131 minus 105, which is 26. Oh, this is going to come out very nicely. When I divide by 13, P is equal to 2, which makes sense because you can't have a portion of a shirt. So when I go back up and look at my question, how many of each kind did she buy? That means I bought 2, or do we have a name? Kristen. Kristen bought 2 plaid shirts and let's see, she bought a total of 7, so that would mean 5 solid. I could have said plain, but I'm going to say solid. 5 solid. All right, hopefully this is all making sense. We're going to do one more together, and then you guys are going to do some on your own. Okay, this is a pretty classic kind of word problem, and this one is a little bit different than what we've looked at so far, so I really do want you to focus on this one. So number 4 says, the school that Mary goes to is selling tickets for a choral performance. On the first day of ticket sales, she sold 3 adult tickets and 1 child ticket for a total of $38. She collected $52 on the second day by selling 3 adult tickets and 2 child tickets. Find the price of an adult ticket and a child tickets. Whoa, I'm running low on battery. We should probably hurry. Okay, so let's go back and look at some important information. So on the first day, she sold, okay, 3 adult and 1 child for $38. And then on the second day, $52 by selling 3 adult and 2 child tickets. And then our question at the bottom is find the price of an adult ticket and a child's ticket. Okay, so again, that sentence at the end is telling us what our unknowns are. So we're needing to find the price of an adult ticket. So I'm going to say let A represent the price of an adult ticket. And I'm going to let C represent the price of a child ticket. Okay, for our equations, now think about how we're going to set those up. This time, notice it says on the first day she did this, and on the second day she did this. So equation number 1 is going to come from the first day. And I'm sitting here thinking, oh my gosh, I just said money goes with money. This is an exception to the rule because we're talking about a total now. Okay, so all of that information that's highlighted in yellow goes together. She sold 3 adult tickets and 1 child ticket for a total of 38. So 3 adult tickets would be 3A. Here's that word and, means add. 1 child ticket, you could put 1C or just C, is a total of $38. Okay, so that's the first equation for day 1. The equation for day 2 is she collected $52 by selling 3 adult tickets and 2 children tickets and collected $52. Okay, now with this equation, notice both of these are in standard form, and I'm also noticing that conveniently, this time I have a common coefficient. So I am going to choose to solve this one by elimination. So I'm going to bring it down here. I am going to copy it again just so I can make sure we understand what's going on. Then we have 3A plus 2A equals 52. Okay, so remember, to solve by elimination, you look for a common coefficient. This time the signs are the same, so that means I'm going to subtract. So everything in the second row gets subtracted from everything in the first row. So 3A, take away 3A. That eliminates. And then we have, oh, sorry about that. I just noticed I wrote this as an A and that should be a C. That was not meant to be confusing. 1C minus 2C is negative C. And then we have 38 minus 52, which is negative 14. So I can't have a negative number of children tickets, so of course I'm going to divide everything by -1, and that means each child ticket is 14. Okay? How am I going to find the cost of an adult ticket? Because it says find the price of both. So remember, I have to substitute this value of C in one of those 2 equations above. And I would probably pick the first one because it looks a little bit easier. So 3A, okay, 1 children's ticket costs $14, so plus 14 equals 38. To solve this equation, I'm going to subtract 14 from both sides. So 3A is equal to 24, which means A, 3 times 8 is 24. So A is equal to 8. Okay, so that means, and again, writing my answer, clearly stating my answer, adult tickets are $8 each. Child tickets are $14 each. Okay. All right. I'm going to stop there. I know I went kind of fast through some of that, so the great thing about a video is you can always go back and look over any of that. You can rewatch the video if you need to. But what I want you to do before tomorrow is finish the last 4 problems. And they are not all exactly the same as what I just went over with you. So you really have to think about, remember, all real life application problems are different. So you're solving number 5 through number 8, and we will go over those tomorrow, and I will answer any questions that you have.